like a few weeks ago, we had a webinar how scaffolding works with SCART and Production Assist, and now we're doing the same thing with Vectorworks and Production Assist and the scaffolding workflow. There is no real functional difference between what Production Assist can calculate or do in SCART compared to what it can do in Vectorworks. So depending on the view on this, so the Production Assist side and the workflow is always the same for this. There are some advantages when drawing scaffolding that SCART has, which makes it really fast, and it's really easy to do sections, and it's really easy to achieve the accuracy that you need to do this kind of things. But it's also possible with Vectorworks. The nice thing with Vectorworks is that it actually allows you to put everything in one program when you're already working in Vectorworks with the trusses in there. So that's a really good thing to get started in there. One thing that you need to know about the Vectorworks thing then is that it requires you to really, really work in details. So the snapping in Vectorworks is good, but it's really easy to snap something that you don't snap. And in order for us to calculate everything, we need the drawing to be accurate. So we need to make it really that it stays in the place where it should be and not like 5 millimeters away with this, because when you have larger drawings, this will make easily problems with this. It is possible though, and if you are an experienced Vectorworks user, it should be really easy for you. But this thing said, the accuracy is the really important thing in here for calculating the scaffolding things. You can fix this afterwards if you know what you're doing, but it's just a pain in the ass. But that's basically the main thing in here. So let's go into the to the thing in here. So the good thing, and I hope this works today, is that you just can use the default library that comes with Vectorworks. So what I'm going is I go to the Vectorworks library, I go to the entertainment thing, there's a folder called stage, and then there's a folder called layer and layer all around. We will start with the around stuff, and I click on this, and we will start on a really simple way so that you see how this actually will work and what is the important thing in here to get started. So we need the standards element, and I use the 4 meter standard in here that we have. I double click. That is something that I don't understand. Wait, that was happening before one time. Revival in folder, and then I can open it. So sometimes, for whatever reason, it doesn't allow me to import this into the drawing. Don't use. Perfect. Going back to this. But I can import it from another drawing. So that's a little bit strange. I didn't dig too much into it. So same thing. Now I'm doing this. So where you import this actually is not important. But you see, once you've placed the layer scaffolding thing in here, it immediately tells you that it is not supported in here. So that there is no connection on this thing that actually supports this thing, which is not a big thing for us. So we will do this a little bit in the process. I just move the scaffolding thing a little bit to the side. I change this to the plan view, and now I have this in here that I see the ledger, the standard in here, so that it goes up. One thing to explain a little bit on how all of this works is that I go to File, Settings, and in there I can click on Renderer and I can click on Show Structure. If I'm activating this, you will see it automatically draws a yellow structure from the bottom to the top in here, which actually indicates what part of the layer scaffolding thing can be used for calculation. That's a feature that is sometimes really useful to check how Production Assist is actually seeing what is going on here, so that you know which cross-section are used and how it will be calculated. So if you just have one standard in here, you won't be really happy. So the easiest thing that I normally find in order to now place multiple of these standards and to do align the 2072 millimeters between them versus the scaffolding thing is to go to edit, and I think there is a duplicate array. The duplicate array allows you, and you see I already typed in the values that are important, to duplicate this in a direction with the needed accuracy in here. And I just click on OK, and I end up with 4 of these columns where it still completes, or where it still complains in here with this that there's no support, which obvious makes sense in here because, well, they are just standing. If you didn't put anything in there, they actually would tip over, but one step after another. So now what we want to do we want to put in the ledgers. For this, it is important to switch to the 3D view. I have a 3D mouse in here so that I can move this a little bit in here. That actually helps quite a lot with this. And I want to put in the ledger. In order for this to work properly, it is important to change the view. So in the shaded view, it's really easy to don't snap the things that you want. So if you go to shaded in here, you see there is a point at the center point of the connection option in here. So this red point. And that is actually something that is really useful in the process. So in order to now import the ledgers, you go to the ledgers, and we have the 207 millimeters in here. It's not really well described that they have only the 207 millimeters because they basically prevent you from seeing there's another 2 millimeters, but well, that's the way it is. So double clicking it, importing it in the drawing, then it's attached to the mouse. And then I can go in here. So I can select this. And now the important part is that you don't snap this, but actually only snap the point in here. So, and then the next thing, oh wait, click. Then it's aligned like this. Now the next thing is also important that you really stay on this kind of thing. In our engineering office, we see quite a lot often that the people, don't have it like almost there, but almost is not perfect. So it's important that this actually is like this, that it can be connected like this. So the drawing accuracy really is a thing that helps us in the process. If you double click it, it also works like this. The nice thing is in here, you go in here and then it also snaps with this. You can do this. Now you see you already, well, let me move this to the side in here. So you see you already have a connected structure, so then it only complains that there is no support on one of the structures because now everything is considered to be calculated together. So what I'm now doing is, well, filling it just to put in the right scaffolding thing in here and actually calculate this the way how I want it. So I see I have it like this in here, and now I can calculate it. For the calculation, well, the supports are missing. There is 2 things in here that you can do with this. So one way, which is the fast and dirty way, is to tell Production Assist that the floor basically acts as a support. So if I'm going into the load combinations and clicking the load combinations in here, there is this use floor as a support. And then you can activate this in here. You also can define the floor level, so at which level the floor is. And then if I'm activating this, this can be calculated in here. The nice thing for this is it doesn't force you to already place in the spindles and stuff like this and the base plates. It's a little bit easier for this to calculate here along with this. That's the first option for doing this. And in the beginning, we first will use this option. And then a little bit later, we actually coming to a little bit more things in here. So now you see the error message is gone away. So you actually can be sure that it can be calculated. If you now click on show combined deflection in here, you see both in Vectorworks and in Production Assist that it actually shows you the deflection figure in here. So this thing in here only has a dead load currently, so it doesn't really do anything with this. So it's really just this one thing in here that has the connection in here with the floor and just this, so nothing else. So what we will now do is I will duplicate this and draw this a little bit higher. So what we want is we actually want to draw something which is a little bit higher with this so that we can see what is possible with this. So for this, I select this. I do select the bottom point in here with this, with the insertion point, and I do move up it to this. Now, same thing, like always, the important thing is the insertion point. So in here, it's really good if you move close to the thing. so that it aligns. Hold the Option key, that actually will be duplicated, and then there you go. It actually will be duplicated it in here. So now we are building the tippy in here. So, well, let's see it, how this works. So I have set it up like this, and we want to make a scaffolding thing. So normally you put in the ledgers in here with some kind of raster. So a good practice normally, just because of the diagonal force, is to go first 1 meter, then 2 meter, or 1 meter, 1 meter, 2 meter in here. We want to put a little stress on this thing, so we immediately will go only the 2 meters up. So I'm selecting this. I either can copy it, or again, I can use the duplicate array function. Say I want 3 of them. I think 1, 1, and the distance from this should be 2. Pressing OK will enter me this kind of things in here, and you see that it actually will duplicate this in here as well, and immediately is updating you the calculation in here. So the next thing is also possible with this. So you select this, you select the right point. So snapping and accuracy is really the most important thing in here, and place it in here. So once you have done this, you have a really basic Vectorworks scaffolding structure in here that you can use. So what we will now do is we will actually put in some more things in here. So what I will put in here is first some fixtures. The way how fixtures and all of the stuff work is exactly the same. So I'm selecting the like for trusses, I'm selecting the fixtures. Where do we have it in here? I'm using this in here, and then I place one fixture. And now the important thing is actually the snapping thing with this. And in here, I think like this: 1, 2, 3, and 4. And you see, while I'm doing this, it's actually reacting to this load. So it's tipping this a little bit out to the outside, the things with the trusses here, and actually puts in the lightning device. So any kind of loads that you have, you basically just can put in here, and it will just work with this so that you come into the other thing. The same thing is true when you now want to put something on top of this so that it's actually like a PR outrigger, or that you want to put a truss in there. So for this, we go to the top plan view, and I go into here with this and select a good truss. So a good truss could be, so it's a 3 meter. So let's use a 4 meter truss in here. And I want this truss going from here to here so that I'm putting it in. You see, it automatically connects with the bottom in here. So we want to move it to the right height. So I'm selecting this, look this, and it is 509. So I'm selecting this truss and moving it to 509. And I think it's in millimeter, my drawing. So I move it up, that is like this. Now you see that you've actually placed the truss like this on it. And every time you're doing this, it actually automatically reacts to this. So there is no real difference between drawing truss structures and then drawing the scaffolding structures. So doing the same thing, duplicating this like this, and there you go. You have now 2 trusses in here that actually do have the outriggers. The cool thing now in here is that you actually also now, for example, can use the load tool in here and place in the load tool. So 1 and 2. And when you're doing this, it actually will add these kind of things automatically out of the box to the truss in here. So it will actually will put in some force in here. So if you go to the cross sections in here with this, show VZ, you see that it's actually put the forces in here. And now you see in here there's a negative force, which actually means that it will be pushed down. And on the bottom, there's a positive force, which actually means this will be pushed up at this thing. So in order to counter level this, I click in here and I click in here, and now the structure doesn't tip over anymore. Well, you still need to secure it to some point, but it's not really that important anymore to do this and come to solution in here with this. So that's the way, basically, how you draw really simple scaffolding structures that you have in here. A cool new feature that unfortunately is coming in the next release in a few weeks is that you actually can assign wind load planes also for geometry. So currently we need to use a little bit of different approach in here, but step by step, I will show you this. So right now we do have our structure in here. So it is loaded like we want it to be. And the next step that we want to do is actually that we want to add more of the wind loads in here. So the wind loads way of the production assist thing. For this, I now disable the yellow lines. So I click on File, Settings, and show the structure with this. And it's like this. It's just a little bit easier for me to see, and I disable the shear phrase, and now it looks like this. So there's multiple options in here to actually put in wind loads in production assist. The easiest way, what we want to do is we do select everything in here, and the layer scaffolding structure is not cluttered, so it's only the base structure. So for this, there is a setting when you go in here, structure, use structure as a wind load plane. If you activate this, the internal cross-section knows how much wind it generates. So if I'm activating this in here, I can select this thing in here, and you will see that it calculates the wind load area. Well, let's us change to something a little bit more. So the wind load area of this is a specific value, and then it calculates you the effective wind load area out of this. Same thing in here for the trusses. So there is a wind load area and there's an effective wind load area with this. So one thing that you already saw when I'm activating it, now it's going to the side. You see that the ledgers are actually attached to this so that they a little bit hold this back in here. But actually it's quite a problem in here currently. Also, if I do show the workload, you will see that both, let's go into here, both the regals, so the ledgers, and the standards are actually overloaded. So if you build such a structure and put in the wind, it actually will get too much wind in here. Currently, what we did is we only told the structures in here that they get wind. For successful calculation here, you also need to update the CF factor with this. Look into the ground support webinar a little bit more for the explanation about CF factors, but that basically defines, depending on the shape of the object, how much of the wind force actually get transferred into real force. Normally, this is a value bigger than 1 because there is push and drag for these cross sections, but the value is always depending. The value 1.8, which is the default value, basically is something like the worst case scenario in here. So that normally is a conservative approach. What we know right now in here, and I quickly use the select same name for this and select all of these and all of these. So I can tell them for this, it is 1.2 because it's a steel tube. So you see now it's gone a little bit down. For the trusses, the bad thing is this is also something. Normally the calculation for this comes to 1.6. Updating this, you see, this also quietly changed a little bit the support on this. The next thing in the calculation when you go in here is actually to set the default wind pressure for this in here. So by default in here, there's a default wind speed and a default wind pressure. So this is something that depending on the values that you want, you automatically can set. For example, a typical thing is that you say, hey, I want to have this at 72 meters per second. So then if you're going in here, so if it's 72, the default wind pressure is only 0.25, which actually will change this in here, would make it okay. So it's not really a good scaffolding, but it still would work in here. So actually it is something that would be okay if you build it like this when the wind speed is like this. So how do I set the correct wind speed for this? For this, you click on the load combinations for this, wind load settings. And there is a helper. So in Germany, for example, there are 4 wind load zones, 4, 3, 2, and 1. And then if you select this, so if you're doing an event in the wind load zone 2, you just select the wind load zone 2, and then it will be updated in here. You see the default wind pressure changes to 0.39, and the default wind speed now is 90 kilometers per hour with this. There's a little bit more into the wind load calculation. It's just not the standard factor, but the good thing is that Production Assist basically does this out of the box. So depending on the high, you need to respect a different factor in here. So when you are outside in Germany, the Eurocodes apply. So till 7 meter, the wind force basically gets a little bit of factor by 1.5. And then from there on, the factor is 1.7 and some other parts of this. And then you see it's increasing every time. For example, in 24 meters, it is 0.6 in here. So Production Assist is smart enough to check every part of the truss if there's enough wind, so how much wind force at this position point here is actually applied. An important thing to know is that we also put in a temporary usage factor. You need to know that these kind of wind loads that you put in there are calculated on a 50 years basis. So basically they check to some level, simplified, what's the highest wind speed in this region that they saw in the last 50 years, and that's the value that you assign to it for calculation. If you only use a temporary, it is possible to reduce this, and the maximum factor here in Germany is 0.7. So they say if it's below 2 years of usage, you can reduce this a little bit because it's really unlikely that in these 2 years you hit the 50-year maximum. So this is basically one option to reduce this a little bit. You see the 0.39 is also quite something. And then if you go to the next, to the wind zone 3, this increases a little bit, and the force the highest, the 0.56, which is also default value in Production Assist, so that you don't do any problems in here. So we will change it back to wind load zone 3, no, 2, and press OK. And you see the calculation in here is automatically updated with this, so that we are in here and do this. And you see there's a slight overload in here, so we need to do something about it. So the easiest way to fix this is to enter diagonals. The diagonals, well, they come from the resource thing. And in here, I am selecting them. So what we need is the diagonals. And there are several of them, so we need the right ones. So we need the 207s. And we don't need the 0.5 meter, but we need the 2 meter. Where do we have them? In here, 207 by 207 meters. So if you're selecting them and importing them, you now can apply them in here so that they are placed correctly. It's a little bit tricky to see them because it's a little bit, well, you need to put them in the right point. But now I have them. So what I do is I entered it in here. You see, entering them, they have a small offset in here so that they can attach to the side, and then it calculates. So adding the thing in here, you will immediately see that actually they do have an offset in here. And now you see it's tilting a little bit because there's only one side in here that is actually preventing the tipping. But you would see this one thing in here would actually make this the 7-8% would make it okay. So in theory, you could build such a thing, but in the practical thing in here, you would not really have a lot of fun with this because, well, it's not really well designed with this. So next thing, same thing, I'm importing this and I'm placing it in here so that we have it like this, putting it in here, and then it's a little bit more in here that goes into this. What I want to do is I want to add something in here, and that's only 1.5. So basically important thing. So every distance between this is 0.5 meter. So we now need the 0.07 by 0.5 meter with this, which I've now imported from the resource manager. I'm searching for the point in here. So the red point, double clicking it, and I have it in here 1, and I have it in here 2. So the interesting thing, and that's why I wanted to show you this, is when you look in here, the bottom is now straight and the top is now straight, but in the middle, actually, it is kind of going to the side. This is interesting because basically it's the same effect if you have this in trusses. So if you don't have a bracing, it actually will deflect a lot more if it has this diagonal. So it's really like a tilting point in here. So on a really basic level, the layer structure is like a big custom built truss where you can assign this where you want this for the calculation in here. So now I have it like this with all the tipping and tilting in here. So now the next step is I also want to add the other diagonals. So I'm going back in here with this, selecting the 2 meter diagonal again, moving a little bit up with this so that I'm here, clicking it at 1 and 2 so that I have this in here. Now you see it's good, and you see now it's almost straight. Only the bottom in here goes a little bit to the side, but this is totally acceptable. So this is fine in here for the actual calculation with this. The nice thing is now, right now, it's not really important. We already picked the worst spot from which direction the wind is coming. So when I'm now tapping in here 45 degree, I can actually change the wind direction of this depending on the thing where this actually goes in here. Why is it so tilting to the side? Well, because 90 degree, we still have these problems in here. So it still goes in here. So it's really rigid in this situation, but it's not really rigid in this. So in order to fix this, we slightly move around. I select this in here. Now the important part with this is in here with this. I select the point. Now I need to do it correctly, that I do this. For this, I think I need to go like this. Yes, 1. Going down a little bit like this, that I have it like this. And in here, I go with this and then 5 like this. So now I inserted at the wrong place. You see that it can't be calculated. So I don't want to select everything, only this one. So select single. So this needs to go away, deleting it and doing it again, the 2 meter with this, selecting it 1, going to 5, oh, like this, and then here, going in here. And same thing in here. So finding the right point and going to the side in here with this, or like this. So now you already have this. Just at the sake of simplicity, I also do the bottom one in here. So I think this needs to be insert in here, and then we, oh, there is, wow, wait, so there's already something with this. And here we go. Now we basically have it cluttered from all the things. Now, when I'm moving the thing again in here like this, you see it's better in here because it's now a little bit more going in this direction. For sure, as I only put in the 2 braces in here with this, these will not go over here. But you see actually now everything is green, so at 82% workload, which is fine and actually can be allowed to calculate this. So what we currently did till now was actually that we used the floor as kind of a support. The next step, what we want to do is actually calculate the ballast that we need for this thing. So, and for calculating the ballast in here, what you need is real supports for this. So it's not that challenging. So what we go is we disable the floor in here, the supports with this in here. And wait, I have this now as, now it becomes gray, says it can't be calculated. And now what I need to do is I actually need to select one of the bases in here. So you can select this in here, so the 60 base, click in like this, and then you can just place this in here like this. So 1 and 2, and you need to move it a little bit, 3 and 4. So you see, it's immediately complaining about failed supports because currently, and that's an important thing in here, these kind of things, they are being set up to only support pressure. And this structure is immediately failing. So when you look into this, it's not possible with the wind that it doesn't tip over. So the easiest way, what I normally do is to do a trick and allow the uplift forces on this. Allow uplift forces basically allows you to allow it to have negative forces in here. So when you click on this, so wait, let us quickly go into another thing with this, like 0 degree, that we have one thing in here. So it will tip over in this in here. And if we do look into this in here, you can go to the support and it has a negative force by 1.34 kilonewton in here. So there is already a negative force in here. You also can show this in Vectorworks. We kind of make a quick jump for this. So I now want to see this in Vectorworks. So you click on resource, you click on labels and background, you click on create label, you edit the label in here, and you click on new object and basically just add the print load field in here. And this print load should show the reaction force in Z. Basically with the print labels, you can do all the markings in here, but we only want this. So I select this, 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 and this. Go to go to the rendering options, click on the show label, and actually activate the print labels in here. Why didn't this work? Okay, there is a bug. It doesn't show it for the symbols, but now it shows it in Production Assist, which is good. So when you see there's a negative force. Negative forces basically make it tip over. So what we need is we need the ballast. The easiest way to calculate the ballast is if you go to selection and, oh, that's not right. If you go to edit and click on the calculate ballast. What it will now do is build calculations from all direction and actually check what's going on. So if you do this, it crashes because I have a bug. Okay. Let me open one of the files that we already have. Use Production Assist in here. So this also works from a little bit bigger systems in here with this. Let me quickly put out the error. So with this, so even if you have structures like this, when you assemble them like this, they also will work. And in here, there's also this. So I go to the plan view. It looks like this in here. And with this kind of thing, clicking on the show deflection, I also can calculate the workload and all of the things in here for this so that we can actually calculate this. And that we also build like bigger arches with this so that this can be calculated. So one thing that we didn't cover so far with this is how to cover now the thing. And we will do this. Basically, it is working pretty similar like the like we did it. Oh, wrong button. No, wrong button, sorry. Like we did it in SCART. You need to draw a polygon. So if I'm going in here with this, selecting it like this, I actually can cover this. In order for Production Assist to see this, you need to turn it into a symbol. So you create symbol. We call this wind load cover in here, pressing OK, and say the insertion point is here. It's not really important where the insertion point is. Oh, look, it already does it at the right thing because it's aligned to this. And then I can calculate it like this. So now I have the wind load in here with this. And in order for Production Assist to recognize this as a wind load plane, basically what you do is you click on use as wind load plane. Then it will use the polygon which is in there as a wind load plane. You click it in here and it will calculate it. And you see now it's pushing it to the side and you're seeing it's also lifting. So if there is wind like this, nothing good will come out of this in here. So that is something where we basically need the support in here for this to properly calculate in here. So the next thing would be here, calculate ballast, and then would write in the ballast in these things and calculate how much in here you need in order for this not to tip over with this. That's basically the way how the scaffolding stuff in here works. So all the Vectorworks symbols are prepared. There are some of the special libraries that don't work so well, but that is something where we, with the next update, have our own library with this. And that is something that you can use for the calculation. An important thing about this, as we now approaching the end of the layer scaffolding thing in here, is ground support calculation with the wind load and so are really challenging. So you need to have somebody who's really experienced with this. So the Production Assist in here is a tool that helps you, but it doesn't really prevent you from doing bad things or entering false data. So the important part in here is really know your limits. The good thing in Production Assist in here, we do have this request check structural calculations. So you can immediately table this in here with our engineering office. And you see it immediately gives you a price so that you have an estimate how much this actually will cost to get this certified, and we take over the liability. It's also fine if you put this in with an overload. We will fix it a little bit later, but that's a little bit the thing in here. We also help you in the process with this, but that gives you an idea how much it will cost. So if you're in doubt, ask us or ask any other engineer to help you with this. So that was introduction in the scaffolding work with Vectorworks. Thank you very much for your attention. So are there any questions about this?
Hey, good morning or afternoon, Maurice. Hey, I had one question about the like the wind plane coefficient, like if that was a wind pass material, or do you have time to touch on that, or is that outside the scope?
So I can explain it a little bit with this. Okay, so let's take this in here. So when you have wind loads, the obvious thing in here is the area. So I changed this to square foot. So the wind comes from, and you can put in the wind load direction. Where do we have it? Boy, here with this. So the wind comes from this directions. So it's pretty obvious that the wind is blowing against this thing. It's really easy to calculate the pressure. So one could think if you have this area, this amount of pressure will actually be applied to this. But it's a little bit different. So there is something else happening because the wind in here is flowing around the structure. And what is happening is that directly behind the structure, it's basically pulling the wind away from the structure. So it's a little bit like a plane. So the wind is flowing along the thing, and the plane, or like the plane, the structure is also pulled up. And that is what is happening here. So there's a part of the wind load that gets applied to the front, and a part of the wind load that gets applied on the back. So the way how you calculate this, unfortunately, is depending on the design standards that you need to use. So for example, the Eurocode calculates this a little bit differently than the RSCE, but in general, they all have the CF value. So a factor that you apply to it so that they have the additional force that comes from the dragging effect behind of it. The other thing is, or where this is similar, so in the car industry, they also give you the so-called CW value. This also gives you how much wind actually gets applied in force for cars. So they try to design the cars that the wind is not pulling it so much and that there's not that much wind force. We don't have this luxury normally in the building industry or for the scaffolding industry to have this amount of thing in here so that they actually work nicely in here so that we can do this. That's this kind of thing. I show a little bit, unfortunately, currently as a digital thing, I only have the German norms in here, but in here we have it in here in the European, there's the Eurocode. Then I just show you the relevant thing. So for example, in here, depending on the roof shape, they define how the forces in here are wielded by this, or where the factor 1.8 comes from. There's a lot of description in here. For example, how normal roofs in here are considered, and then it gives you DCF values from here. So the problem is it kind of takes quite of some effort to notice and some knowledge to put them in place. So the wind load factor 1.8 is actually quite high. So it's a good starting point if you're not really sure what you're doing to get an idea of what could happen. Normally it's possible to reduce this. We're working on tools that make it a little bit easier to calculate this, but this is not currently in this update, but not in the next update, but it's planned then for the next thing in there. Ben, does this explain a little bit for you, or?
Well, I was also curious, what if that material allowed wind to pass through? What if it was
Okay.
a mesh?
Okay, the main problem with this, and we have these questions quite often, is so when you look at normal like planes or stuff like this, they don't really give you a value how much wind is passing by. So if you don't have a specific value by the manufacturer, you are forced to assume that this plane basically is wind transmissible. A good example for this, where this actually applies, for example, that's also how LED walls is the OOE LED walls. They do have one line which is specially optimized for wind load, and they actually did make tests on the wind channel. But that is something that they provide you with documents, and then you can take it over. But if you don't have any documentation on how this actually reacts to wind, you need to use the worst case scenario in here.
Yep, understood. Thank you, Maurice.
Okay, then the next question from Thomas is here. So for the ballast, there is two options in here with this. So one thing that you see in here is actually that it has drawn the ballast tubes with this, and that you also could add the ballast in here with this. There are multiple ways on how to do this in here. The simplest thing in here is that when you calculate the ballast, it actually calculates you the amount of weight that you need for this specific spindle for not tipping off. And it will write it into the weight in here. And with this, you can actually calculate the needed ballast also on the shape of the object in here, depending on this. What is also possible in here is to draw these kind of tubes in here like this. So like we have in here. As I said, not everything is actually updated in here with this so that they do have the right calculation. So in here, you see, you don't do this. So the easiest way to do this is when it doesn't show the yellow structure that we talked about is to edit by yourself. So I go to show structure and enter this in here. And you see, for whatever reason, this doesn't have a structure. So you go in edit, edit defining resource. And there is a structure, okay, but the structure is 207, and you see it's at the same point. So the easy thing is I need to do it like this. So I need to put it at 0, and then I need to set the cross section correctly, which is the U cross section in here. So we say for layer U, save. And when you then do this, you see actually it's immediately is connecting them with this. I move this a little bit to the side in here with, I move this to the side, and then this is also possible to calculate in here with this. So now you can place weights on these columns in here that is connected with this. So unfortunately, this is an extrude, so let me delete this in here with this so that we don't have this anymore. And then let me add a weight for this. So for example, in here, and it didn't like this, you can add the weight in here like this, and it will actually automatically calculate this. If you then add, wait, it's at the wrong place. But that is basically the way how you would do it. So this is already connected like this. Let me use in Production Assist and connect it with the plugin in here so that I do have this thing. Oh, it's a new version. With this, you see actually has this thing in here. So if you add a point load at this places in here that is actually pushing it, it would also do it. So if I'm now setting the right height for these things in here, so like this, that they are placed like this, and then put in like 500 kilos, you will see it actually will react to this. I have already the beta version in here. That's why it shows the errors in here. But that is basically the way how you put in supports. You have the decks in here, and you put in the line loads, and then you can remove this from here. Thomas, does this answer your question? Oh, for which countries do we have the?
Perfect. Yeah, thank you.
Genau. Which region? So we currently, if you need a region, ask us. So it's a little bit challenging for us to add all the regions and all the standards in here. But the easiest way is in here, we do have the US, we have France, United Kingdom, Netherlands, United States. And basically just select them and gives you the image, or if you go to the United States, it also gives you the wind load zones for the United States in here. Then, if there are no more questions, thank you very much. I will send you the recording a little bit later and talk to you later. Bye-bye.
Thank you. Have a nice time in the sun.
Thank you.
Thank you. Yep.
Bye-bye.